All right, so we're going to start with percentiles. The percentile is the percent of values in a distribution that are less than the individual's data value. And we're going to use those and find z-scores. So standardized scores, or z-scores, tell us how many standard deviations from the mean the value falls and in what direction. And we can calculate the z-score by taking the value minus the mean and dividing by the standard deviation. All right, our first example, finding and interpreting percentiles. The dot plot shows the number of calories in McDonald's salads in recent years. Find the percentile for the premium bacon ranch salad with grilled chicken, which contains 260 calories. So it's this dot here, the 260 calories, just past 250. There are 6 dots that are less than that dot out of 11 total dots, which comes out to be approximately 0.55. So we would interpret this as the premium bacon ranch salad with grilled chicken is at the 55th percentile of this distribution. All right, the premium bacon ranch salad without chicken is at the 18th percentile of the distribution. Interpret this value, and how many calories does this salad without chicken contain? All right, so we're going to interpret that value at the 18th percentile first. So about 18% of the salads have fewer calories than the premium bacon ranch salad without chicken. All right, because it's the percent that's less than the value in question. All right, so now we need to figure out how many calories are in there. Well, what is the 18% of 11? There's 11 dots, or 11 different salads. So 0.18 times 11 gives me 1.98, and so the 0.18 was probably rounded, so that's about 2. So only 2 of the 11 salads have less calories than the premium bacon ranch salad without chicken. So if I count over from the minimum, that means that the salad would have approximately 140 calories. It'd be this one that's a little bit in front of 150. So approximately 140 calories. All right, another example, finding and interpreting z-scores. The speckled caiman is a crocodilian reptile that lives in Central and South America. Researchers recorded the mass in kilograms of 14 caiman. The data are shown below along with a dot plot and summary statistics. Find the standardized score, or z-score, for the caiman that has a mass of 15 kilograms. Interpret this value in context. So I have all of the data, I have a dot plot, and I have the summary statistics, which is the mean, the standard deviation, minimum quartile 1, median quartile 3, and maximum. Okay, remember we knew how to find that stuff from the last chapter. So I'm going to take that 15 kilograms and the mean and the standard deviation from the summary statistics and plug it into the z-score formula. So z is equal to 15 minus the mean, 9.81, divided by the standard deviation, 3.93, which gives us approximately 1.32. And I'm going to interpret this. Remember, the z-score is how many standard deviations we are from the mean. So the caiman's mass is 1.32 standard deviations greater than the mean caiman mass of 9.81 kilograms. All right, our last example. U.S. skier Mikaela Shiffrin is one of the top skiers in the world, earning many victories, including 3 consecutive World Cup wins. In a recent race at Squaw Valley, she won both the slalom and giant slalom events. Shiffrin's times in the slalom was 99.480 seconds. The mean time for the slalom was 103.870 seconds, with a standard deviation of 3.247 seconds. In the giant slalom event, the mean was 138.711 seconds, with a standard deviation of 1.109 seconds, and Shiffrin's time was 136.42 seconds. Relative to her competitors, which of Shiffrin's 2 times, the slalom or the giant slalom, was better? Justify your answers. So I want to compare these things, but they have different means and standard deviations. So I'm going to put them in terms of z-scores. All right. So for the slalom, her time was 99.48 minus the mean time divided by the standard deviation gives me a z-score of negative 1.35. So she was 1.35 standard deviations below the mean, which means she was faster than the average. In the giant slalom, I'm going to do her time minus the mean time divided by the standard deviation, which gives me negative 2.07. So again, she was 2.07 standard deviations below the mean, so she was faster than the average. So Shiffrin did better relative to her competitors in the giant slalom because her time was more standard deviations below the mean, where smaller times equals a faster run.
All right, thanks, and see you next time.